Welcome to another video lesson for Integrated Math 2. Today we're going to look at how we can represent the perimeter and area of different shapes with polynomials. Let's get started. For our first example, we're going to go ahead and write a polynomial expression in standard form for the perimeter of a rectangle. But before we can do that, we want to remind ourselves what it means to be the perimeter. So the perimeter is going to be the distance around the outside of any given shape. For our shape here, the perimeter, we would take the length of all four of our sides and add them all together to represent the perimeter. One thing that will make this a little easier for us is remembering the property of rectangles that opposite sides are congruent. So if one side is 7y minus 9, the opposite side is going to be congruent and will also be 7y minus 9, which means I have two sides that are both 7y minus 9. Looking at my other length, 10y plus 2, again, opposite sides being congruent for a rectangle, I have two sides that are going to be 10y plus 2. Now that I have an expression written, we want to go ahead and do some simplifying. So I'm going to start by multiplying. We're going to multiply our monomial on the outside by the binomial on the inside. And when I multiply that together, we're going to get 14y minus 18 plus 20y plus 4. And now I want to go ahead and combine like terms. So I can combine my two y values together, 14y plus 20y, and that will get me 34y. And then I can also combine the negative 18 plus 4, and that's going to give me minus 14. And now I have an expression that represents the perimeter of this rectangle in standard form. For our second example, we're going to go ahead and try and find the perimeter for the following triangle. Again, perimeter is going to be the length of the outside of the shape, so I want to find the length for all three of my sides of my triangle and add them together. Each side of my triangle is a different length, so I'm just going to write down the length of each side and add them all together. To begin with, we have 3x plus 1 as my shortest side. And then I'm going to add to that 6x plus 2 for my next side. And then for our final side, we have 8x minus 2. Similar to our last example, we're going to go ahead and try and combine like terms. So I can combine my x values together. I have 3x plus 6x plus 8x, and that's going to get me 17x. And I can also go ahead and combine my other terms. So I have 1 plus 2 minus 2, and that's going to simplify to be plus 1. So now, again, I do have an expression that represents the perimeter or the outside distance of my triangle. Our next problem is an application problem. So we have Benito's apartment shown in the following floor plan. So we can see the diagram on the right here. We have his floor plan. And he plans to put baseboard along the perimeter of the living room, which you see at the top left, the dining room, which is the bottom left, and then the bedroom, which is the top right, not including the hallway. So I'm going to go ahead and identify those three rooms. Again, we have the living room, and then we have the dining room. And last but not least, we have the bedroom. We're going to find the perimeter for each one of those. So for our first question here, we want to express the perimeter of each of the rooms as a polynomial. Looking specifically at our living room, we can see that we have two different lengths here, giving us a rectangle. So if we go back to our first example, for rectangles, opposite sides are definitely going to be congruent. So if one side is 4x, the other side is also going to be 4x. And that tells me that I have two sides that are 4x. And then I also have another set of sides that are going to be congruent. In this case, it'll be 4x plus 2. So I have plus 2 times 4x plus 2. I'm going to go ahead and distribute, and we get 8x plus 8x plus 4. And if I combine like terms, then we get 16x plus 4. So that would be for our living room. Looking at our dining room, we're going to apply the same strategy. Again, we're going to have a rectangle. We can see that one length is 3x plus 1, so the other length is also going to be 3x plus 1, giving us two sides that are 3x plus 1. And since the dining room is below the living room, it's going to have the same length for its other side, 4x plus 2. So again, 4x plus 2, and then using properties of rectangles, the opposite side is going to be congruent. So we have another two sides that are 4x plus 2. When we simplify things a little bit by multiplying or distributing our monomial on the outside, we get 6x plus 2, again distributing, and then plus 8x plus 4. And if I combine like terms, we're going to end up getting 14x plus 6. So that would be our expression for the perimeter of the dining room. And then last but not least, we're going to find the perimeter of the bedroom here. So looking at our bedroom, once again, we see we have a rectangular shape. One of the lengths is going to be 4x plus 1. Again, we have two sides that will be congruent, so both will be 4x plus 1. And then for the top here, we have 4x minus 3. Okay, so we have two sides, two sides that are 4x minus 3, and two sides that are 4x plus 1. Again, we're going to go ahead and distribute our monomial on the outside, and we get 8x minus 6 plus 8x plus 2. And if I combine my like terms together, then we get 16x minus 4 for our perimeter of the bedroom. For part B, to find how many feet of baseboard Benito needs, we need to factor in the fact that each room has a door. So for our living room and our dining room, we have a door in the very middle, and that is going to be a length of x plus 2. And the other two doors that we see in the bedroom are going to have a length of x minus 1. So we're going to take all of our sums for the perimeter of each room, and then we're going to subtract the length of the doors. Let's find the perimeter of our rooms added together first. So I'm going to take my 16x plus 4, and I'm going to add to that 14x plus 6, and add 16x minus 4. When I combine all of my terms together, I get 46x plus 6. Now to that, we're going to take out the length of the doorways. Again, if you look at the living room and the dining room, they both share an x plus 2. So we're going to take that out of the perimeter for the living room and also for the perimeter of the dining room. So I'm going to be subtracting 2 times x plus 2, again, because of the doorway in the living room and the dining room. We're taking that perimeter out of each room. We're also going to take out 2 times x minus 1 because the bedroom has two doors. All right, we're going to simplify this just a little bit. So we have 46x plus 6 minus 2x minus 4 minus 2x plus 2. And when I combine all my terms together there, now we get a total of 42x plus 4 as our total perimeter for baseboards needed for Benito's apartment. When you're trying to find the area for a geometrical shape, each shape is going to have its own specific area formula, but sometimes we don't want the entire area. Sometimes we only want the shader region. So when finding the area of a shader region of a polygon, the area of the non-shaded region is going to be subtracted from the whole polygon. Let's go ahead and take a look at a couple examples. Looking at our example here, we have a rectangle, and you can see that within our rectangle, the entire area is shaded, so I want all of the area. And for our length and width, we see that we have a binomial expression representing those. We have 3x minus 8 and x plus 6. So for this, we would just go through the formula of finding the area of a rectangle, which would be length times width. And we're going to plug in our length and our width based off of the binomial expressions. So we would have 3x minus 8 times x plus 6. And we can go ahead and multiply this together by either using the box method or by distributing. I'm going to go ahead and distribute. So I'm going to take each term from my first binomial and multiply by each from my second binomial. We get 3x times x, giving us 3x squared. And then we have 3x times 6, which would be plus 18x, minus 8 times x, which would be minus 8x. And last but not least, we have negative 8 times 6, which would be minus 48. Our two middle terms both have an x in them, so we can go ahead and combine them, which gives us as our final answer 3x squared plus 10x minus 48. And now we have a trinomial that represents the area of our rectangle. For our next example, we have a triangle. Again, we can see the entire triangle is shaded, so I want to find the area of the entire thing. So we're going to go through the normal formula for the area of a triangle. Just to remind you of that, the area for a triangle is going to be 1/2 base times height. For our base, we see that we have 2x minus 3. And then for our height, we see that we have 4x plus 10. So I'm going to go ahead and plug those into our equation. And we get 1/2 times 4x plus 10 times 2x minus 3. Again, we can go ahead and multiply our binomials by distributing or by using the box method. I'm going to go ahead and distribute once again. So we get 4x times 2x, which would be 8x squared. And then we're going to get 4x times negative 3, which would be minus 12x. And then we have 10x times 2, 10 times 2x, which would be 20x. And last but not least, we have 10 times negative 3, which would give us minus 30. Again, we can go ahead and combine our two middle terms, and let's not forget about our 1/2 on the outside here. So when you combine those two middle terms, we now have 1/2 times 8x squared plus 8x minus 30. And for my last step here, I'm going to go ahead and distribute my monomial term on the outside to all of my terms on the inside, which would give me 4x squared plus 4x minus 15. And that would be our trinomial expression representing the area for our triangle. For example here, we have a square to begin with, and we can see that some of the square is shaded and some of the square is not shaded. So our strategy here would be to find the area of the entire square, and then we'd find the area of just this non-shaded part and subtract it. So looking at our square, we can see that the length is x plus 3 and so is the height. If we wanted to find the area for our square specifically, we would multiply x plus 3 times x plus 3. If we distribute correctly, then we get x squared plus 3x plus 9, which simplifies to be x squared plus 6x plus 9. Now we want to go ahead and try and find the area of the non-shaded region. So looking at that non-shaded region, we can see that it's a triangle. And going back to our area for the triangle, it would be 1/2 base times height. Our base would be x plus 3, and our height would also be x plus 3. So I'm going to go ahead and plug that in here. Again, 1/2 base times height, which would be, again, x plus 3 times x plus 3. And notice that we've already multiplied together x plus 3 times x plus 3. So I'm going to go ahead and substitute in what my answer was, which is now going to be 1/2 times x squared plus 6x plus 9. And I get x squared over 2 plus 3x plus 9 over 2. And what we see here is now I have my area for my square, I have my area for my triangle, and I can go ahead and subtract the two to get the area of just the shaded part. So I'm going to go ahead and do that. I'm going to subtract the entire expression. And when I subtract things, I'm going to go ahead and line up things based off of their corresponding degrees. So I can start off with x squared minus a 1/2 x squared. Then we have plus 6x minus 3x. And finally, plus 9 minus 9 over 2. So I've kind of matched up corresponding parts based off of their degrees in descending order. And when I subtract everything, x squared minus 1/2 x squared is going to be 1/2 x squared. And then 6x minus 3x would be 3x. And last but not least, 9 minus 9 over 2 is going to be 9 over 2. So now we have our final expression representing the area of just the shaded part of our shape. Here again, we see that we have a square to begin with, but we don't want to find the area of the entire shape, just the shaded region. So what I'm going to do is find the area of my shaded region and then subtract the area of the non-shaded region. So from my shaded region, I have a square, and it looks like the length of my square and the height of my square, if I combine these two, is going to be 2x. So the area of my square is going to be 2x times 2x, which is going to then be 4x squared. If I want to find the area of the triangle, I can find the base and the height for my triangle. Knowing that I have a square, the base is going to be 2x, and my height for my triangle is also going to be 2x. So finding the area of that non-shaded region, going off the formula for the triangle, is 1/2 base times height, or 1/2 2x times 2x, which should be 1/2 times 4x squared, which should end up being 2x squared. So I have my two areas, the area of the entire shape, and then have the area of the non-shaded region. If I go ahead and subtract those two areas, I'll get the area of the shaded region. So we have 4x squared minus 2x squared gives me 2x squared as my final area for the shaded region. All right, we have one last example here where we're going to again try and find the area of just the shaded region. And our strategy is going to be the same. We're going to find the area of the entire shape and then subtract the area of the non-shaded region to get the area of the shaded region. Looking at my shape, I can see that I have a rectangle. One side of my rectangle is going to be 7x. The other side of my rectangle would be this x plus this 4x for a combined total of 5x. So if I want to find the area of my rectangle, it's going to be 7x times 5x, which is now 35x squared. The next step is to find the area of the non-shaded region. So I can see that I have this triangle. The height of my triangle is going to be 4x, and I know my diagonal is 5x, so I can use that to help me figure out this missing side by using my Pythagorean formula. I'm going to label this missing side as b. So for our Pythagorean formula, we have the hypotenuse squared is going to equal our missing side squared. So 4x squared plus b squared, which gives me 25x squared equal to 16x squared plus b squared. I'm going to go ahead and combine terms here. So I'm going to subtract 16x squared on both sides. And that gets me 9x squared equaling to b squared. And from here, I want to go ahead and take the square root to finish solving for b. And the square root of 9x squared is going to get me 3x. So I have found my missing side to be 3x. And again, we need that to find the area of that triangle, because that's going to end up being the base of my triangle. Going back to the area for our triangle, it's going to be 1/2 base times height, so 1/2 3x times 4x, which is going to be 1/2 12x squared. And that simplifies to be 6x squared. Okay, so we have our two areas. We have the area of the entire rectangle, and we have the area of the non-shaded triangle. I'm going to go ahead and subtract those two to find the area of my overall shaded region. So we have 35x squared minus 6x squared, and I get 29x squared as my final answer for the area representing the shaded region. All right, that does it for our notes for this section. Go ahead and get started on the homework, those practice problems, and good luck.